Hello guys, so in this class what we are going to learn? We are going to learn about circuits. Now what are called circuits? Like when you will call some arrangement of wires and switches and some electrical components as a circuit. So we will be talking about circuit at beginning. Circuits. Okay. So see, we know that the flow of electron causes current. Now that means current is a rate of flow of charge through some circuit. So now what is a circuit? Circuit is a path through which electron can flow. Now in the circuit we can have many components, like we can have a resistance, we can have some sort of equipments like bulb, speaker, whatever. We can have such things. Mostly we uses resistances and rarely we uses some sensors. That depends on our requirements. Now the whole thing is connected with a battery. So a circuit can be of two types. One is called open circuit, one is called closed circuit. So what is an open circuit? The open circuit means the path will not be completed. So the electron can go from one direction like this, but somewhere they have to stop. So here they are stopping because the path is broken. So when this thing will happen, we will call this as open circuit. Okay. And when we have some kind of closed path, then we will be called as closed circuit. Now though the electron flows in this direction, but for convention we take the direction of current in opposite sense. That means in which way the electron is flowing, we will take the current in the opposite sense. So you can say that rather we are not bothered about negative charge flow, but we are thinking about an apparent positive flow of charge. So flow of positive charges, we are bothered about this. Okay. So this is called a circuit. So circuit is nothing but a path through which charges can move. Now why charges move? Charges move because of the difference between 2 points. So if say this is my A point and this is my B point, so charges will flow only when these points will be with different energies. So here if the energy VA is higher than VV, so if VA is higher than VV, only then the charge will flow, positive charge will flow from A to B, because charges want to stay in the lowest possible energy states. Okay. Now in case of the closed circuit, this closed circuit, the inside, we can say that this whole circuit is a loop, or we also use another term for this as mesh. So you can call it loop or you can call it mesh, that depends on you. So that means the current is flowing in this case the current is flowing in clockwise sense. So this is one mesh. Now we know that when a charge will flow from this point to that point, it wants to release its energy. Now where it will release its energy? Now you can see that up to this portion the whole path is very clear, so there is no such opportunity for the charge to lose energy. But here we have one resistance. So resistances are the place where charges can dissipate some of the energy as heat energy or light energies. So in case of resistances, there they will lose some energy. So whatever will be the energy at this point, so this point and this points are the same point, because between them nothing is there, no other components are there. So this point and this point, if we talk about, let's say this is our C point. So in this 2 points, the energies will be different, because VA will be higher than VC, because when the charges were entering at VA point, it has some energy, but after entering, it has lost some of its energy, and now VC will be the remnant, or the remainder energy, you can say remaining energy. So obviously VA will be higher than VC. Again, in this resistance it will lose some energy. So that means in case of VC will be higher than VV. So how much energy is being lost here? The amount will be VA minus VC. And how much energy will be lost here? The amount will be VC minus VB. So if this is resistance R1 and if this is the resistance R2, I can simply write this as VR2, which is VC minus VB, and this one I can write as VR1. Okay. So what is the total energy difference between VA and VB? That will be this, because this point and this point is same, because there is no such component. This point and this point is same, because there is no such component. So I can say that this total V is VA, which is higher, minus VB. Whatever was their total energy, that is being utilized in these two resistances. Okay. So this is the thing, this is the way that a charge moves around the circuit. Now there is some sort of, like, we know that using Ohm's law we can sort it out, like where the current is how much and where the voltage is how much, because this is called voltage. So we can sort it out. But today what we will be discussing is Kirchhoff's law. Now Kirchhoff's has two laws, so that's why it is laws. One is KCL, Kirchhoff's current law. So what is that? Kirchhoff has told that if you have 3 junctions or 4 junctions or something like that, so if you have more than 2 junctions, then if the currents are like this, so these two currents I1 and I2 is entering. So what kind of junction is this? They are talking about some junction like this. Let's say this is resistance, this is another one, and there we have another one, here one, and then we have something here. So you can see that current is going like this, here the current is going like this, and here the current is entering. So this junction we are talking about. Okay, so we are bothered about this junction. Acha, here 3 are there, so we have drawn 4. Okay, acha. So now let's say this is I3 and this is I4. So the Kirchhoff's current law is that the algebraic sum of the current at some junction will be 0. So that means, let's say the entering you are taking as positive. So I am taking as entering as positive. Moving away, I am taking as negative. Moving away means I3 is going away from this junction, I4 is going away from the junction. So if the entering is positive, so I can write I1 plus I2, then minus I3 minus I4 is equal to 0. So this is the Kirchhoff's current law. So in short form we can say that Kirchhoff's current law is summation of all the currents n is equal to 0. Okay, so this is the Kirchhoff law. Summation means the algebraic sum. So this is Kirchhoff's current law. Now another law that Kirchhoff has is called KVL, which is the most important one, Kirchhoff's voltage law. So Kirchhoff voltage law is a little bit different. It says that, so we are doing with only one loop, but later on we will be doing with more. So let's say we have battery 1 here and one more battery we are having here. So you can see in this case, let's say this battery is dominated one. So V1 and V2. V1 is higher and the current is going like this. So if the current is going like this, we have seen in the previous one that current is going like this. That means this portion, in which portion current is entering, that portion is having higher energy values, higher potential energy, right? So here also the current is flowing like this. That means this point will be higher in potential, whether this point will be lower in potential, right? So as this point is higher in potential where the current is entering, we can take this point as positive because this is little bit higher. And respected to this one, like if you with respect to this one, you can say that this term is negative because here the potential is less compared to the previous one. Again, it is entering here, so this side we can take as positive, this side we can take as negative. Here again it is entering here, so this is positive, higher energy, and this is lower energy comparatively. So let's say this is the resistance R1, R2, and this is R3. Okay, so Kirchhoff voltage law say that the summation of algebraic sum of all the voltages will also be 0. So current law says that algebraic sum of all currents are 0. This says the algebraic sum of all voltages are 0. So let's say I is the current flowing through the circuit. So some sort of energy is dissipated here, that is one voltage. Some sort is dissipated here, that is another voltage. So this is my VR1, this is my VR2, and this is here some sort of dissipation is there, so this is VR3, and then we have V1 and V2, the voltages of the cell itself. So it is entering, the current is entering here, so this side is positive and this side negative. We can see this side negative and this side positive. Okay, so current is going like this. Now if you move with the current, we can see that if we start from this point, then we can say that the first, when we move through the current we have a plus sign at beginning. So I can write as plus VR1 plus VR2 plus VR3. Then again we have positive side when where current is entering, so plus V2. But now we are entering to negative side at first. So you can see here the negative sign. So that will be minus V1 equal to 0. So this is the Kirchhoff's voltage law says. Now VR1, VR2 we can find out using Ohm's law, because we know that V is equal to I into R. This is our Ohm's law. So VR1 will be IR1 plus IR2 plus IR3 plus V2 minus V1 equal to 0. So this is Kirchhoff's voltage law. Using these two laws, Kirchhoff voltage law and Kirchhoff current law, we can solve for many problems. Now what kind of problems we can solve? Let us find out. So here I give you one example. Let's say I have this circuits. So we are first doing with two circuits only. Okay, and let's say this is the flow direction of current I'm taking at beginning. So let's say this is 10, this is 5, this value is, let's say, 2, 2, and this is also 2. For our simplification I am taking like this. Achha, the current is I here, and you don't know the current. Now you can see that here we have two loops. This is the first loop and this is the second loop. Okay, so this is the first loop, this is the, actually I'm using another color so that there is no such confusion. So this is our first loop, this is our second loop. Now you can see here that this is also 2. Okay, now we have to find for each loop at first. So the equation we have to find out. So I can see that here the total current I is entering, but I has two way to go, either this way or that way, and I don't know which way they are going. So let's say this is my I1 and this is my I2. That means the I is being separated into I1 and I2. So here for this point I can write the equation KCL, that is the Kirchhoff current law, as I minus I1 minus I2 is equal to 0. That means I is equal to I1 plus I2. I have one equation here. Okay. Okay. Now we will be finding out Kirchhoff voltage law. So for first loop we are finding at beginning. So for the first loop I can write here. So give the plus and minus sign at beginning. So this is plus because current is entering, minus, this is plus, this is minus, and this we have minus plus. So the current is entering here. So that will be so here we have to find out voltage. So resistance is 2 and current is I. So I can write 2I plus 2I. Here current is I2 I have taken, and the resistance is 2, and the current is entering in positive side. So I can write plus 2I2. And then you see here I have to find out current again. So now you see I2 is this one, and again I1 is coming through this one. So this has to become I again, because in this point they are separating, but in this point they are meeting again, right? So that means this will be I. Acha. So I is entering here in the negative side of the battery, so I will write minus 10 is equal to 0. So there we have one equation. The next equation will be for the second loop, and if I write this, so you can see the first, we are starting from here, this point. So I1 is entering, so this side will be plus, this is minus, this is plus, this is minus. So you look here now, so this will be plus 2I1 plus 2I1, because here also I1 current is entering because it is the same path, right? Okay, now it is entering in the plus side again. Okay, plus side again. So here this will be again plus 5, because this is voltage. 5 is not resistance, it is voltage. Okay, so I'm writing here, so this is voltage. These are the ohms, matlab resistances. Okay, so now let me write this as also with this color. Okay, so now you see here we are here, right? Now we are moving in the same direction like this. So the next part is this one. Okay, so if you move here, you will first encounter minus at beginning because you are moving this direction, right? So you have to move in same way. You cannot skip this part because you are looking into all of the components in this loop. So this one is there, and you are entering, when you are going, you are entering the negative side at first. So that's why it will be minus, this will be 2 and I2, because I2 is the current there. So now you can see we have lots of equations. So in the next line what we will do, I am writing this equation again. So that is 2I, this is the first equation we had, 2I plus 2I2 minus 10 equal to 0. So I'm taking that 10 that side. Now one thing you know, that I is equal to I1 plus I2. This one, right? Equation 1. From equation 1 we can find out. So instead of I can write 2I1 plus 2I2 plus 2I2 is equal to 10. So I have 4I1, sorry, I have 2I1 plus 4I2 is equal to 10. So this is my equation number 2. Okay, and the next equation, what was that? 2I1 plus 2I1 plus 5 minus 2I2 is equal to 0. So here what I am doing, I am writing 4I1 minus 2I2 is equal to minus 5, because this 5 I am taking that side. So this will become my equation 2. Now we just have to solve for these two equations in order to get the values of I1 and I2 easily. So what I can do, I can directly multiply the lower side with 2 and I can easily find out. So what I'm doing here to solve 2 plus 2 into 3, we get, so this by 2 plus we get, so in the next page we have 2I1 4I2 is equal to 10, because we are not doing anything, and plus we are adding, now this we are multiplying with 2, so that will be 8I1, then this will be minus 4I2, so 5 will be multiplied with 2, so that will be minus 10. So I'm adding everything, so I will get 10 I1 is equal to 0. So I1 is coming as 0. Okay, I1 is coming as 0. That means this side no current will flow, right? That means this side no current will flow. Now see one thing carefully. If I find it for let's say I2, so what will be there? To find out so I got I1 equal to 0. See, so if I put here for any of the values, I will get I2 is equal to 10 by 4, right? So I2 will be 10 by 4. So that is how much? 2.5 it will come. Now the question is, how I1 is becoming 0? See, here I have taken arbitrary values, right? I have taken the values from my mind. So sometime it happens when you have enough voltages in this side, so when, and the thing is that when the current will not flow, say when let's say you have a resistance here and this side your potential energy is V and this side potential energy is VB, and let's say the both side potential energy is same, so the electron will not flow, the charge will not flow. That means I'm just telling that when a charge flows because one side energy is higher than another side, right? But what if the both side values are same? That means the charge will not flow. You will get a zero current, right? So in this case, what happened? In this case, you can see here that this point, and this point, the potential must be same, and as a result the I1 which was flowing through this one will be 0. So we have taken I1 at beginning, but ultimately our values, like equation has told us that yeah, the I1 has to be 0 because in this side no current will flow. That means the value, potential values here and there is same. Okay, so that is the important thing to note. Okay, so if you get some value equal to 0, don't think that you have done something wrong. If you have done with procedure like we have done here with procedure, you can check out the second one. We are, again I'm just repeating, this was I1 I have taken. So at beginning we are talking about this resistance, so I got 2I1 plus because I was going through this. Then I went here, so that was 2I1 again. Okay, then I came here and that is also positive encounter, so plus 5. Then I have to go up also because I'm checking throughout the loop, and now I encounter negative at first, so that's why it is minus 2I2, because here in this branch I2 current is flowing, right, and that is equal to 0. So when you are sure about your equations, don't think about answers ki why I have gotten this equal to 0 and this equal to something else. Okay, so this kind of math we cannot solve usually with our equivalence of resistances laws. Okay, so that what you say, that finding out equivalent resistance and using Ohm's law will be very difficult in this scenario. So that's why we use Kirchhoff voltage laws to solve out this kind of circuits. Now you can do with 3 circuits, 4 circuits. So more the circuits, more will be the variables, because here you can see that 3 branches are there, so I got 3 variables at beginning. Then I reduced my equation to 2 variables only, I1 and I2. Okay, then I sort it out. So more loops you have, more variables will come, more equations you need to solve out, but you can do it at least. Okay, so this was the class for today, and we will be solving more this kind of problems in our further classes. So bye bye till then.